So, we've got the 2003 multiple choice most missed problems. Okay, we got problems that we're going to be going over up on top. So, if you got one of those wrong, maybe you can just skip to the video wherever that problem is.
They don't know which ones they got wrong. How do they know which ones they got wrong?
You guys don't know that yet. I'm about to send it out pretty soon.
I'm not sending that out. I'm just sending your overall score, so watch them all.
I'll have it to you sometime today. Alright, so what we want to do here, guys, number 2, this is just basic U sub. Okay? I'm going to choose U to be negative 4x. Means du dx is going to be negative 4. Alright, so du equals negative 4 dx. Or negative 1/4 du equals dx. Okay? So we're going to do our u sub over here. I'm going to integrate e to the u now. Okay? Because u is going to be negative 4x. dx is actually going to be negative 1/4 du. Now guys, once we have du here, my boundaries better be matching it correctly. Okay, so I want to figure out what u of 1 is and u of 0. Well, u of 1 is going to be negative 4 times 1. So that gives us negative 4. And we're going to do u of 0 is going to be, well, negative 4 times 0. So we get 0 out of that. So we're really going to integrate from 0 to negative 4. Now the boundaries are not correct on that. Okay, so we're going to have to do a little flippity floppity. I also have this negative 1/4. I'm going to bring that out front right now. So if this was a negative 1/4, I'm also switching my boundaries. So this is going to be now from negative 4 to 0. This is going to be a positive 1/4. E to the u du. Alright, so now we can just integrate that. Well, the integral of e to the u is just going to be e to the u. Okay, we still had our 1/4 out front. I'm going to evaluate it now from negative 4 to 0. So all I got to do is plug in my points. I got 1/4. Okay, e to the 0 minus e to the negative 4. Okay, maybe you want to say e to the 0 is really going to be 1 here. So we get 1/4 times 1 minus e to the negative 4th. Okay, and now we want to look at kind of what our possible answers are here.
So here's our packet, and it looks like they might have distributed, and it might be D.
Yep, that looks exactly like it.
1 minus e to the negative 4th on top, and the 4 in the denominator. So most likely, if you miss this one, my guess would be you either forgot to change your boundaries to be in terms of u, so you never have to change back in terms of x, or maybe you forgot to flip and negate. Those would be thoughts.
Did you sub wrong? Something like that.
Yeah, something like that. Okay,
Cool.
moving on. So number 18 is on the non-calculator part 2. And even though it's going to take me a tiny bit of time, I'm going to do this anyways. So we're given a table of values. And we have some values just going by ones from negative 4 to 4 for x. And then we have some values for g prime of x. So this is 2, 3, 0, negative 3, negative 2, negative 1, 0, 3, 2. And the stem of the problem says the derivative g prime of a function g is continuous and has exactly two zeros. Ugh, I can't even talk. So that just means like this is remaining unbroken as you're connecting all these values of g prime. And it has exactly 2 zeros, which looks right? You have 2 spots where g prime equals 0. So they're just kind of telling you what you already can see off the table. So nothing's tricky. Selected values of g prime are given in the table above. If the domain of g is a set of all real numbers, then g is decreasing on which of the following intervals. So if we kind of do what Hernie often does where he just like writes something out. If I want to know where g is decreasing, then don't I want to know where G prime is less than 0, or where G prime is negative? So, I mean, I have information about G prime. Maybe I even put it on a sign analysis chart. So this sign analysis would go from -4 to +4. And it looks like the critical points where, I mean, that's what we mark, right? Critical points, it says it's continuous, would be at -2 and +2. That's where G prime equals 0. And this is what we do if we were doing a sign analysis, little dots down. And I would label it G prime and what that concludes to me about G underneath. So G prime from -4 to -2, well, we already have the -2 marked as 0. And at -4 and -3, we have positive values. So right here is positive, and G would be increasing. In between -2 and +2, all of these values are negative. So we would be decreasing. And in between 2 and 4, our values are positive, so we're back to increasing. So my guess is those of you that missed it because you chose letter A. And letter A said that the values where G, remember we're looking for G being decreasing, was like this. And that letter option is wrong, because right at -2 and right at +2, your values of G prime are not negative. They are 0. How can this equal, you guys right there? Some of you did that wrong on an AP free response question. You wrote your interval like this with closed brackets when these were the spots where your derivative equaled 0, and that's a wrong justification. These would have to be open brackets to be an okay way to state that. And we really don't know what's going on in between -3 and -2. We're just kind of assuming that. And that's why the letter option is wrong on A2, because we really don't know that. The correct answer is B. Like, we really know it's between here and here where our values for G prime are negative. And we can include -1 and we can include +1 because, yes, they are negative values for G prime at -1, 0, and +1, and those are where G is going to be decreasing. So it's sort of tricky. I'm guessing, like I said, a lot of you missed it because you chose A. But right at the critical points of -2 and +2, if G prime is equal to 0, then you can't equal those spots when you're saying you're decreasing. So A's out, and the answer should be B. Okay, so there's number 18, and we're going on to number 27. So number 27 is actually something we have not talked about yet. It's one of those things that we talk about during this time of the year when we are reviewing for the AP exam. Now remember, you guys, this was clear back in 2003. So some of you got 27 right, and you could have got there like kind of doing some algebra stuff that gets messier. But I will tell you that from every multiple choice packet here on out, you can't get there in an algebra way. You have to know this trick. So you will get used to seeing this problem. If you were taking a normal AP exam, I would guarantee this problem would be towards the end of your multiple choice problems on the non-calculator, because a calculator wouldn't help you. Sometimes the calculator problems still are non-calculator, really. But it's about the inverse, okay? So if you read it for number 27, it says, let f be the function defined by f of x equals x cubed plus x. If g of x equals f inverse of x, remember that notation is for f inverse, and g of 2 is equal to 1, then we want to find the value for g prime of 2. So there is a distinct way to do this problem every single time. And if you can go through like this way to do this problem, you can get this problem right. And even though there's not multiple choice on your AP exam this year, I don't know, they could throw something like this on a problem that's for your response. I don't know. So you need to know this fact. So instead of trying to do anything too crazy, let's go back to what we know about inverses. So if you were in my pre-calc class or Mr. Herney's pre-calc class, we kept trying to drill into you, because we know it comes up in calculus, what are the 5 important things that you need to know about inverses? So the domain and range switch, or they're interchangeable, which means the x's and y's switch. So if you know a point on your original function is 3, -7, then on the inverse, it would be -7, 3, right? Don't they flip-flop? Don't they switch? That's also why graphically, an original function and inverse have the symmetry over the y equals x line, so our diagonal line that has a slope of up 1/1, that's where we would fold our paper, and our original function and the inverse would lie on top of each other. And yes, like one of the important things to know is how to find an inverse. You switch x and y and solve for y, but that's actually not going to get you typically anywhere on this kind of problem. You have to know the last thing, that when you compose an original function and its inverse, actually both directions, right? And you work from inside out, don't both ways you get x. It's the only time that composition is commutative, and you can just write it like that in either order and get the exact same answer, only when two functions are inverses. That is actually the fact that we're going to use. So didn't they say that g of x was f inverse? So if I compose my original f with g of x, which is the inverse, the fact that I should know is that it has to give me x. The composition has to give me x when I compose an original function and its inverse. So now I have a rule. So I'm just going to take the derivative of both sides. So see if you can like follow this idea. You guys, this left-hand side, isn't this a composition, a function inside a function? Isn't this chain rule? This is chain rule that was on your time test. Oh, it's the derivative of the outside, f prime, leaving the inside unchanged, times the derivative of the inside, g prime of x. Right? Chain rule. Derivative of the outside, leaving the inside unchanged, times the derivative of the inside. Whatever I do to one side, I got to do to both sides. So if I take the derivative of the left-hand side, I got to take the derivative of x, and the derivative of x is just 1. I'm taking the derivative with respect to x on both sides. Well, the reason I wanted to do that is I want to find g prime of 2. So if I want to find g prime of 2, a derivative evaluated at a certain number, maybe it would help me to find g prime of x first, the derivative in general terms, in terms of x first. Well, I have g prime of x. All I have to do is isolate it on the left-hand side. So these are multiplied together. Don't we undo multiplication with division? So we're going to divide both sides by f prime of g of x to isolate g prime of x. And I'm sure this is not the only time we will do this kind of problem, and it will come up again, but it's going to be on your multiple choice packets from here on out. So g prime of x in general terms is 1 over f prime of g of x. So that means now all we have to do is plug in our value of 2. So now if I want to find g prime of 2, and I replace this x with 2 on the left-hand side, then I want to replace this x with 2. Oh, it's 1 over f prime of g of 2. Well, guess what? They gave us g of 2. G of 2 is 1. So this is my x value, and this is my g of x output value. So g of 2 is the answer of 1. So g prime of 2 equals 1 over f prime of 1. And f prime of 1, I want to find my derivative evaluated at 1 for f, but I have a rule of f, and it's super easy to take the derivative of this. It's just a polynomial, right? So it's just power rule, f prime of x would equal 3x squared plus 1. And if I want to find f prime of 1, I would just plug in 1 for every x I see. So 3 times 1 squared plus 1, I'm finding the instantaneous rate of change of f at 1. 1 squared is 1, times 3 would still be 3, plus 1 would give me 4. But remember, the location of that is in the denominator. So g prime of 2 should equal 1/4, because that 4 was down in the denominator. And that is letter B, as in boy, out of our options. So that problem will definitely be something that comes up again. So last one from the non-calculator, Mr. Herney's going to rock and roll on number 28.
All right, number 28. All right, so let g be a twice differentiable function such that g prime of x is greater than 0, and g double prime of x is greater than 0 for all real numbers x, such that g of 4 equals 12, g of 5 is going to equal 18. What is the only possible value up here for g of 6? Okay, so we got to understand really what we're talking about here when we're saying that g prime of x is greater than 0 and g double prime of x is greater than 0. All right, so understand, if g prime of x is greater than 0, that means g is always increasing. If g double prime of x is always greater than 0, that means g is always concave up. Okay? So our function is always increasing, always concave up. So really it's going to look kind of exponential type of thing. Okay, but basically for every distance we go, we keep going up by a higher and higher amount as we keep going. Okay? So if here we're at we'll say that's going to be 12. Okay. My next one we're going to be at 5 is 18. Okay, really think about what's happening. We go over 1 and we're going up by 6. Okay? So if we go over 1 more, if we are increasing in concave up, we need to be going up by more than that same amount. We don't really know how much, but it has to be going up by more and more and more every single time. Okay? So if from 4 to 5 we went up by 6, that means 5 to 6. If we are increasing in concave up, we have to be going up by more than 6. Okay, so this is going to be at 24. So that means pretty much anything larger than 24 would be an acceptable answer. And if you look at all the possible answers, okay, the first 3 are less than 24. The third or fourth option is 24. Okay, remember this is increasing in concave up, so it has to be going up by more than 6. So the only possible answer would be
E.
Yeah, E, 27. Cool.
Okay. So now we're into the calculator active part. And on number 77, it's one of those times where, okay, it's on calculator active, but you don't use your calculator whatsoever. So they have this graph, and I'll just like quickly redraw it. And they have a few values marked on our x-axis. And they tell us it's the graph of f of x. And it kind of looks something like this. And this is letter capital A, and this is letter capital B, that's somewhere in between some negative x value and 0, and then letter capital C. Okay? So it says, all right, the regions A, B, and C in the figure above are bounded by the graph of the function f and the x-axis. Okay. If the area of each region is 2, so we know each one of those areas that we accumulate would be 2, what is the value of the definite integral from -3 to 3 of f of x plus 1 with respect to x? So again, you guys, this is something that you're gonna, in a typical year, see on the multiple choice part, whether it's on calculator or non-calculator, and they want you to understand that line that I always tell you, that calculus is beautiful. So if I'm trying to do a definite integral, and I have something in function notation, but I'm adding or subtracting something else that's not in function notation, isn't the definite integral of a sum just the sum of the individual definite integrals? So if I break this apart and go, oh, it's the definite integral from -3 to 3 of f of x with respect to x to finish out this operation, plus the definite integral from -3 to 3 of 1 dx with respect to x to finish out this operation. Now I can do each part, because this is the graph of f of x. So this is not the only way to do the problem, but it's the most efficient way to do the problem. So if I want to know the area I sweep out from -3 to 3, and they told me all the areas were 2, you just have to realize, oh, well, A is underneath the x-axis, so the area we would sweep out would be -2. B is above the x-axis, we're sweeping the normal direction from left to right, so that would be a +2 that I accumulate. But C is back below the x-axis, so that would be a -2. So these two would cancel, and I would have -2 that I'm dealing with right now. Plus, this is an integrable piece, right? Like this is something I can integrate. If I'm trying to integrate 1 with respect to x, don't I add to the power? So it would become x, right? 1x, evaluated from -3 to +3, because it's a definite integral, so I don't have to have my plus c, and I'm evaluating it from -3 to +3, so it'd be -2 plus, I'm going to do some brackets. Don't we plug in our upper boundary first, 3 minus, plug in our lower boundary, a -3, and this would really turn into adding, and 3 plus 3 would be 6, and -2 plus 6 would give me a final answer of 4. And you never pick up your calculator, and 4 is letter C out of the options. So like I say, it's not the only way to do the problem, but this is the most efficient way and the way that they're really trying to test you. Do you understand that calculus is beautiful kind of thing?
Alright, so number 80 is going to get into our theorems here. So let's just first talk about our theorems before we talk about this problem. We really have IVT, EVT, and MVT. Okay, so intermediate value theorem, extreme value theorem, and then the mean value theorem. So for all of them, they must be continuous. Okay, must be continuous on the closed interval. However, that is all IVT and EVT need. Okay, so remember, IVT is really saying if you got a point here and you got a point here, all the points must exist in between that at some point. Okay, meaning if this is like x equals 2 and this is x equals 5, okay, then all the y values in between x equals 2 and x equals 5 must exist somewhere between 2 and 5. EVT is just your extreme values. Okay, basically that's just saying there must be an absolute minimum and there must be an absolute maximum if you're continuous. If you think about that, if you got a point here and you got a point here, right? This would be your absolute max, this would be your absolute min. Other things could be going on here. You could go curvy like that. Hey, we got an absolute max up here. Okay, now we got absolute min, absolute max. But no matter what, an absolute max and an absolute min must occur. The only time really an absolute max or an absolute min would not occur be as if you had like a vertical asymptote and it would go up forever. Right? That would be no absolute maximum. Okay, but now that you have a vertical asymptote that's not really continuous, and that is dependent on continuity. Okay, IVT, EVT must be continuous on the closed interval. MVT, now we're talking AROC equals IROC. Okay, whenever you hear MVT, that's what you got to think, AROC equals IROC. So this is going to be like f of b minus f of a all over b minus a is going to equal the instantaneous slope at f prime of c, where c is going to be some point in between a and b. Okay, but for this to work, we must not only be continuous, but we must be differentiable. Okay, so just going through those very briefly. Hopefully that helps ring a bell. Okay, so let's read this problem. The function f is continuous on the closed interval -2 to 1. Okay, so if it's continuous, that means we could have IVT and we could have EVT. And differentiable on the open interval -2 to 1. Alright, so now we have all three of our theorems working for us. If f of -2 equals -5, so I'm just going to put a dot on my graph here. -2, -5. And f of 1 equals 4. Okay. Which of the following statements could be false? So I always like to draw that. Just it helps me out with my IVT. Okay. A is saying there exists a C where C is between -2 and 1 such that f of C equals 0. Alright, so what this is saying is I must have an output at 0 somewhere between x equals -2 and 1. Well, according to IVT, that must be true. Okay, at some point, if we're continuous, to go from here to here, we're going to have to cross the x-axis. Okay, I don't care how you do it, but eventually you're going to have to cross the x-axis, and that's all A is saying here. Okay, so the question, keep in mind, is asking which of the following could be false. Okay, so A is guaranteed to be true here, due to IVT. B, there exists a C between -2 and 1 such that the derivative is going to equal 0. So as soon as we start talking about derivatives in these types of problems, we got to be thinking MVT. Okay, we are differentiable. So I'm going to do AROC equals IROC and see if it works out. Okay, so the only way you can guarantee a derivative is ever going to be something is basically through MVT. So average rate of change. So we know the average rate of change is going to be 4 minus a -5 divided by 1 minus a -2. Okay, over the instantaneous rate of change, they're saying that that must equal 0 here. Okay, so this is really going to be 4 minus negative 5, which is 4 plus 5, over 1 minus negative 2. Okay, so really what MVT here is guaranteeing is that f prime of c must equal 3. Okay, so right now I'm thinking b is not guaranteed in any way. Okay, but let's go ahead and look at these other ones.
You just proved D.
Yeah, I just proved d actually. Okay, so honestly, if they're giving you two different derivatives must equal something, it's probably going to be one of those two, just from the other problems I've seen in the past. C is saying there exists a C, where C is between negative 2 and 1, such that f of C equals 3. Well, my output must equal 3 at some point here. Okay, there's no way I can go from negative 5 up to 4 without going through 3 at some point, at least once. Okay, E, there exists a C where negative 2 is less than or equal to C, less than or equal to 1, such that, okay, so after you guys see this notation, don't freak out about it. Okay, all it's saying is there's really an absolute maximum, okay, and that's going to be guaranteed through extreme value theorem. Okay, if they're saying absolute minimum, it would be f of C is less than or equal to f of x. Okay, that would be absolute minimum.
Yeah, because this notation means there's some output that's smaller or equal to all the outputs. Absolute min. There's some output that's greater than or equal to every other output. Oh, absolute max. And you're already continuous, and that's the only hypothesis for EBT, so that has to be true.
I was just thinking about maybe having your little note sheet. Maybe you want to write that means absolute max, absolute min. I don't know. Whatever helps you guys out. But anyways, this answer is going to be, what do we say, B?
B.
Yeah, B. Alright. Because MVT does not prove that, and all of our other theorems don't prove it either. Okay? So like I said, guys, think about what you want to have on your little one-page sheet. Quick reference.
And of course, if you were really had like the packet and you were really taking the test and could write on it, you probably would have written like true next to A, and true next to C, and true next to D, and true next to E, and you're trying to find the one that's false, and the only one left that's false would be B. That's a good way to approach it too.
Alrighty, number 87.
Now we're actually going to use our calculator on Calculator Active, Mr. Herney.
Yeah, so the function f has a derivative given by f prime is going to equal the square root of x over 1 plus x to the third. What is the x coordinate of the point of inflection for the graph of f? So guys, if I'm thinking point of inflection, okay, point of inflections occur if f double prime changes sign. Okay, that's the first thing that always goes into my head. However, I'm given a graph of f prime, and we're allowed to use our calculators. Okay? So, if I graph f prime really quick, okay, my graph is actually going to look like this. Okay, one thing to point out here is, you notice how there's no graph to the left of 0? Well, x cannot be negative in values. Okay, so that's why our graph really starts at x equals 0, and then it's going to go to the right. This is f prime. F prime is increasing and then decreases. Well, when it changes from increasing to decreasing, isn't that when my second derivative is changing sign? Okay. So you go ahead and look at it on the calculator here.
And kind of giving you some hints. So we put this into Mr. Herney's calculator, right? So there's our original rule for f prime, square root of x in top. Definitely use pretty print over 1 plus x cubed. But when you look at your answer choices, wait, this is 87, not 86, huh? On these answer choices, all of the answer choices are very small. So we have 0, and we have some numbers in between, 0 and -1, and just one answer choice that is bigger than +1. So maybe that's like a little bit of a guide about how to make your window. So Mr. Herney did his window from -1 to 2 for the x's, and just went by ones. And then he just did the y's small, -1 to 1. And maybe that's not what you start with, but maybe you start with -5 to 5 and then you narrow it down. But when we hit graph, there's the graph he's talking about. So really, aren't we looking for where the first derivative changes from increasing to decreasing or decreasing to increasing, because then all the little slopes would change sign, and the slopes of the first derivative are the second derivative. So we're going to try and find the maximum, and that's going to tell us, remember, that they test you on zeros and intersection, but you might use something like min or max when you're graphing a graph. You would not try and want to take the derivative of that first derivative by hand. You would have to use quotient rule, and you'd have all sorts of gross stuff going on with like the radical and changing it to 1/2 power. Like that is out. That is not what this problem is. So this is actually a problem where we're using our calculator. So we want to be to the left of that maximum, go to the right hand side of that maximum. Yes, Mr. Calculator, guess it for me. And we only were asked the x value, which is 0.4725. So that rounds up to approximately 0.473. And that answer choice is letter B. Like, are you kidding me? No. How are you going to find anything and set that equal to 0 and solve? You're not getting anywhere. Okay? So there's one where we actually use our calculator.
Yeah, that'd be F double prime, not F prime, like I originally wrote. But yeah, so your answer should be. Did you already talk about what the answer was?
Yep.
Yeah, B. Cool.
B. So 88, I'll probably just show you guys so that we don't have to write out all 5 of these graphs. But let Mr. Herney read it to you and give you the gist of what the problem's saying first.
All right, so on the closed interval, 2 to 4, which of the following could the graph... I can't read. Which of the following could be the graph of a function f with the property that 1 over 4 minus 2 integral from 2 to 4 f of t dt equals 1. All right, so guys, what that's really telling you or showing you is that's fave, right? We integrate a function from a to b, and then we multiply by 1 over b minus a. Okay, so we're really asking which of these graphs has an average value of a 1. Okay, so do you want to sketch? We can sketch these out real quick.
Well, and if you just clean this up a little bit, this would turn into 1/2, right? And we're looking for a graph that when we find the area between 2 to 4 of a graph, that our final answer for fave has to be 1. Well, if this is 1/2, doesn't this area have to equal 2? So that 1/2 times 2 would give me a fave answer of 1. Okay? So all graph, Herney's graphing D and E, so I'll graph A, B, and C over here.
You got A, B, and C?
Yep.
All right. So I'll just start talking about these. I forgot what the answer one actually is, but let's just talk about what fave actually is for these. So if I integrate from 2 to 4 here, okay, isn't this just going to be a rectangle? Actually, it's going to be a square. Base of 2, height of 2. So this area is going to be 4. But then we're going to multiply it by 1/2 because we want the average value of it. So we divide that by 2. My average value is going to be 2 here, which makes a lot of sense because it is 2 and it's constantly 2. It's always 2. So the average value should probably be 2 of that function. Okay, I'm going to look at this one. Okay, we find the area underneath this curve. So it's going to be the base 1 plus base 2 because it's going to be a trapezoid. So we take 1/2. Base 1 is 1 plus base 2 is going to be 3 times our height, which is going to be 2. Alright, so this is the area under the curve here. My 1/2 and my 2 cancel. 1 plus 3 makes 4. This area is 4. Okay, so when we take fave of it, we're going to have to multiply it by 1/2. So the average value here is once again 2. Alright, so if you look at this, guys, we start at 1, we go to 3. The average would have been halfway in between it because this was linear.
So neither one of those are what we want, which is a fave value of 1. So D and E are out.
Look at that C over here. Okay, so what we have here are 2 little triangles. Okay, so the area of this triangle is going to be 1/2. Base, which is 1, height is 2. 1/2 times 1 times 2 is going to be 1. Okay, this little triangle here is going to be the same. It's also going to be 1. So my area under my curve here is going to be 1 plus 1, which is 2. So to find phi of this, I'm going to take 2 times my 1/2, which is going to give me an average value of 1. Okay, that's actually the exact thing that we're trying to find. Okay, we're trying to figure out when or which one of these has a phi of 1, average value of the function to be 1. If you look at like this one, it's going up really quick. It definitely is going to be between 1 and 2, but it's going to be closer to 2 probably.
And how are you going to accumulate areas on something that's like not geometry? So these would like not be like as doable to get a value of 1. So.
Yeah, and then this guy's going to be an average value of, well, it should be more than 1 again too. Alright, but yeah, that should kind of ring a bell for you. Like if you've got things you don't know how to find the area underneath the curve of, like there's no way to figure out what the average value of those functions are without an equation. Okay, so that should be kind of a clue to not pick those.
Okay. So that was 88, right?
I think so. Did I do 87?
Yes, 87 was the calculator one. Okay, so we're on our last one, which is number 89, which even though it's on calculator active, again, really doesn't have much to do with the calculator. And if you are watching this and you're like, oh, I definitely missed that problem, you guys, this is one that you just can't miss. Like, you can't miss it. It's too algebra-y, it's too, like, just do the math, you gotta get it right. Like, kind of the one we started with way back here with U sub and having to change the boundaries. Like, you can't miss that. So 89 says, let f be a differentiable function with f of 2 equaling 3. So doesn't that mean on the graph of f we have the point 2 comma 3? And let f prime of 2 equal negative 5. Because that's not a point. Doesn't f prime mean the derivative at 2 equals negative 5? So the instantaneous rate of change at x equals 2, this is for the graph of f, right? It'd be the slope of f right at 2 would equal negative 5. So if you want to think about it like as a slope, like that's fine too. And then we have this other function, and it says then there's this function g, and g of x is defined to be x, and it's squashed next to, so I'm doing a dot to indicate multiplication, x times f of x. Which of the following is an equation of the line tangent to the graph of g at the point where x equals 2? Oh, we want to find an equation of a line. Oh, what 2 things do we need? Oh, Mr. Herney, what 2 things do we need to write an equation of a line?
A point and a slope.
All right, and it's the equation of a line for g. So we got to go, okay, if they only told us the x value was 2, we don't have the whole point yet. So if we don't have the whole point yet, don't we take our original rule for g and plug in a 2 as our input so we can figure out our output? And that means plug in a 2 for every x we see on both sides. So g of 2 would equal 2 times f of 2. Oh, maybe that's why they told us what f of 2 was. So f of 2 is equal to 3. And 2 times 3 would give us 6. So our point that we're trying to use in our equation of our tangent line is 2 comma 6. For our slope, if I want to find the slope at 2, right, the instantaneous rate of change at 2 for g, I'm trying to find g prime of 2. But maybe before I find g prime of 2, I should find g prime in general terms, g prime of x. So I'm taking the derivative of the left-hand side, and that means whatever I do to one side, I got to do the other side. But you guys take the derivative of this right-hand side, don't you need to bust out product rule? So it would be the first times the derivative of the second, f prime of x, plus the second, f of x, times the derivative of the first. Well, the derivative of x with respect to x is just 1. Take every x you see, plug in the instant we're talking about, which is 2. So it'd be 2 times f prime of 2 plus f of 2. I really don't need to keep my times 1. That's multiplicative identity, so that's not going to change anything. F prime of 2 they gave me, the instantaneous rate of change of f at 2 was negative 5. So this would become 2 times negative 5. Plus f of 2 was equal to 3. I've used that once, now I'm using that a second time. And it's okay not to have any parentheses here because multiplication is squashed together and we're grouping this together before we take care of our addition. It's the correct order of operations. So we would have negative 10 plus 3, which gives us negative 7. Although some of you had, on something that I graded sometime in the last 2 days, something where you didn't use parentheses and it was times a whole group and you lost points on your free response because you didn't have parentheses there. It was something on free response. So now I have my slope, and if I want to write an equation and I have a point and I have a slope, don't I just bust out point slope form? So y minus 6 equals my slope -7 times the quantity x minus 2. And then you got to look at your answer choices because sometimes they might leave it in point slope form and sometimes they might distribute and turn it into slope intercept form. You don't need to do that if it's free response, but if it's multiple choice and that's the form it's in, you got to do that. But it looks like all of these are mostly in point slope form. So the one that it looks like it matches up with, the only one that has a slope of -7 is letter D. So there's our last one. Okay? Last minute thoughts?
Nope.
All right, that should help you guys on some things, and definitely go back and watch that inverse problem again if you need to see it. It was number 27. That's so different than anything you've seen before, and it will keep reappearing.